In this part we're going to create a messages.yml so that the user can enter custom messages for the plugin to use. The messages will support mini message format and custom placeholders. We will also create a simple command API to handle command arguments easier, and we will create subcommands to set the locations of a game, so the lobby and the spawns for each team. We're going to start with the custom messages config. So first let's create this file. I'm going to call it messages.yml, and then we're going to create a handler class for that. So create a new class in a config package, and I'm going to call it messages. Then this class needs a constructor with a file. So let's create it, public messages file. This will be the file of the messages.yml, and from that we're going to create a configuration object. So create a globally scoped variable, private final file configuration config, and then inside the constructor we're going to assign a value. So this.config is equal to YAML configuration.load configuration file to load the supplied file as a configuration. And then what I like to do is to set a header in the config to inform the user that mini messages can be used, and also link to documentation. So to create a header, do this.config.options.set header. And then inside here you can pass a list of strings, and each entry will be a new header line. So type list.off, and in my case I'm just going to paste the message that I always use. So in here I just tell that mini message format is supported, I link to the documentation, and I also link a mini message viewer. After that we have to of course save the config, so type this.config.save, pass the file, and then wrap that in a try-catch block. And now inside this class we're going to have two methods to get messages. The first one will return a component, get message, and it will as a parameter expect a message type. So message type, and this is something we haven't created yet. So we create it here. It will be an enum message type, and for now it's empty. We will fill this out later. And the second method will also return a component, get message type, and additionally it will expect a tag resolver, and in fact multiple tag resolvers. This is what the three dots mean. This means that you can pass one or multiple tag resolvers, and those will be our placeholders. And the first method will just use this method but with empty tag resolvers. So return get message, pass the message type, and we're going to use tag resolver empty. And then inside here we're going to load the message from the config, and we use the message type object to get the path. So let's create a path attribute here, private final string path, and create a constructor and a getter. Then inside the get message method we're going to get the message from the config. So final string message string is equal to this.config get string, and the path will be message type get path. Then we check if a string with this path could be found. So if message string is null, so if a message at this path could not be found, then we're just going to return a default not found message. So component text not found. And we can actually create a static variable for that, not found, and at the very top here private static final component not found is equal to this. And then the way we want to have it is, for example, in the messages.yml we have something like command only for players, and then red only players can execute this command. And we also have a prefix here, for example blue, and then SkyWars. You can change that to anything you want, of course, and maybe put a reset at the end. And we're going to create the messages methods that it automatically preprints the prefix to every message that we get from the config. So in order to do this in the constructor, we need to get the prefix somehow from the config and save it globally. So private final component prefix, it has a default value of component.empty, and then inside the constructor we're going to get the prefix. String prefix is equal to this.config get string prefix, and then if the prefix is not null we're going to update the prefix variable, so it shouldn't be final actually, with this.prefix is component.text prefix. And we're going to remove any spaces in front or behind the prefix with trim. And now, as you can see, the prefix includes mini message characters. So in order to pass them, we need to change something here. First, get the mini message formatter in this class, private static final mini message, call it and this is equal to minimessage.minimessage. And then we can just take this prefix.trim and put it inside deserialize to pass the mini message tags. And then inside the getMessage method, we can just return prefix.append space.append and then append our message that we have here. But same as before, we want to pass the mini messages. So do deserialize and pass the message string. And this is already it for the messages.java. So you can close it now. And now we're going to update the project to use the messages from the messages.yml. So for example, inside the SkyWars command, import the messages with private final messages, and then create a new constructor. And now we can use messages.getMessage. For the message type, we need to create a new message type. And this is just to avoid typos. You could do this without the message type enum, but I like it this way more because it's a little bit cleaner. So for every message, we're going to create a new enum constant. And I'm going to call this one command only for players. And then we need to fill in the path because the constructor expects a path attribute. And the path will just be the key of the message in the config.yml, in the messages.yml. So in this case, common, okay, I made a typo there, command, in this case, command only for player. So copy this and paste it here in the constructor. And then here we can pass message type.command only for player. And then since we changed the constructor of the SkyWars command, we need to go to the SkyWars Plugin class and update it. So here it expects a messages object now. So pass it and create it. Final messages is equal to new messages. And it needs a file. This will be the messages.yml, this one here. And we can get a reference to that with new file, get data folder as the directory, and the name will be messages.yml. Add a semicolon and import. And now we need to actually copy the file from the resources directory to the plugin folder on the server. And we can do this in the onload method with save resource, then the name messages.yml, and pass false to not override it if there is already a messages.yml. And then when you start the server, you can see in the plugin directory, we now have a messages.yml with our header and with the messages we defined. Now if we try to execute the command, you can see that we get our custom message with the prefix before that. And this will be the concept that we're going to use throughout the whole plugin to get our messages. And the next thing we're going to do is to load our existing games from the config when the server starts. And for that we need to make a change in the game class. In the last episode we implemented configuration serializable and the serialize method to save a game into a config. And now we need to create a deserialize method to load games from a config. Public static void deserialize. The parameter will be a map with string keys and object values called data. And then inside here we just need to build a game object with the data entries that we specified here as the output. So create a new game with final game is equal to new game. And then you can see we need a game's settings object, and inside the map it will be available under the key game settings because we specified it here. So let's get it with data get, then game settings, and we need to pass this to a game's settings object like this. And then we can return the game. And this needs to be of return type game, of course. And now to load the games from the config, we're going to go into the game manager and create a new method for that. So public void load games. Then first we need to check if there are any games in the config. And to do that, we're going to get the configuration section under which the games are saved. The final configuration section game section is equal to plugin get config, get configuration section, and games, because this is how we defined it here. You can see every game is saved under the games configuration section. And then if the game section is not set, then we're just going to return because there are no games to load. And otherwise we're going to load them. So for string game ID, because each game is saved below a random UUID, as you can see here. And we can get those by using the game section and getting the keys. And because we just want the top layer, we're going to pass false. And then we can get the game from the config with final game. Game is equal to plugin get config.get. Then we need to enter the path. And this is games dot and then the game ID, which we got from here. And then since game implements configuration serializable and the deserialize method, we can just cast this to a game. And then we can save this game to a games list, which we create here. So private set game games, and this is a new hash set. And in the for loop, we just need to add the loaded game to the set with this.games.add game. And then after the loop, we can print a message with how many games have been loaded. So plugin get logger.info loaded %d. This means a placeholder for a number. Games. And then we can replace this with the number of games with .formatted and then enter the number of the loaded games, which we can get from this.games.size. Now let's try that out on the server. And then if we create a game with /SkyWars, then you can see the config is now being generated with our game. And then if we restart the server, then you can see that the game has not been loaded because we forgot to call the load games method somewhere. And we're going to do that in the main plugin class in the onEnable method right after we created the manager. So here call manager.loadGames. And then let's try again. And then as you can see, it found the game and loaded it. And now that the games can be loaded, we can continue with the commands. And for that, we're going to create a simple argument API so that we can add arguments easier to the SkyWars command. So in the commands packages, create a new class and call it argument executor. It will be an interface. And inside here, we're going to define a few methods. First, an execute method. This will be the place where we put the argument logic and it will expect a player and arguments for the command. Then the next method will be the get usage method so that we can create a help overview with the argument executors. And the last one will be the get description method. Then in the SkyWars command class, we can remove those two lines because we will extract them later into a new subcommand. And now first we need to check if the user specified any arguments. So if args.length is 0, this means if there are no arguments, so if the user just executed /SkyWars. And if this is the case, we want to send the player a help message, send help, pass the player. And now at the very bottom, we create this method, private void, send help. It expects a player argument. And inside here, we are going to loop through every available subcommand for this command. So for this, we need to have a way to track all the available subcommands. We can just do that with a map here at the top, a private static final map. The keys will be strings and the values will be argument executors. This is our arguments map and it's equal to a new hash map. And then in the send help method, we can just loop through every available argument with a for each loop. So for argument executor, argument in arguments.values. And we use values and not keys because in the map our argument executors are saved as values and not as the key. And then inside here we're just going to send the player a help message. So player send rich message. And this is a message I do not want to make configurable in the messages.yml. You can do that if you want, of course. And I want to send in blue color /SkyWars, then a placeholder for the subcommand, then in gray color with a dash the description, which is another placeholder. And this time I use %s instead of %d because in this example we use strings and not numbers. So .formatted. To replace the placeholders, the first one will be the argument name, so argument.getUsage, and the second one will be the description, so argument.getDescription. And we can actually extract that to a global variable, call it help format, for example, and we can define it here at the very top, private static final string help format, and paste that here. to make the code a little bit cleaner. And don't forget to return after you send the help message. Then the next step is to get the argument the player entered. So we are here if the player, for example, entered /SkyWars create, and we want to save this create into a variable. So final string argument, and this is args 0 and to lowercase. To lowercase makes it easier to search for the argument. And then we get the argument executor for this argument. So final argument executor, this is equal to arguments.get, and we pass the argument. Then we need to check if this is an existing argument for this command, if argument executor is null, and then we're just going to send the help message again and return. Otherwise, we're going to call the argument executor and on that the execute method to execute the argument, then pass the player and the arguments. And this will just forward the command traffic to our argument class. And now we can create a new argument. I will start with a create argument to create a new game, and I'm going to do that inside the command package in another package called arguments, and I will call it create game argument. Then here we need to implement argument executor and implement the methods. The usage will return create and name because we want to give our games a name, and the description for this argument will be create a new game. Then inside the SkyWars command we need to register this argument inside the constructor. Type arguments.put. The key will be the name of the argument, so create in this case, and the value will be the new create game argument. And now let's check that out in the game. And you can see if we don't pass any arguments, we get our help message. And if we do create, nothing happens at the moment because we have no content in our execute method. But before we continue with the execute method, we will add tab completions to the SkyWars root command so that we can see the arguments like in the game mode command, like this. And this is pretty easy as well. Since we implemented tab executor and not command executor, we have on tab complete method here. And I'm not going to go into detail on how tab completions work. I already talked about them in detail in episode number 7 of the beginner series. So inside the onTab complete method, we first check if the args.length is 1, because we want to do tab completions for SkyWars and then the first argument. And then first we create a new list of strings with all the valid arguments, which is empty for now, but this will be the list that we're going to return. And in between that, we need to filter out the valid arguments based on the input that the player has already typed. And we're going to use the string util class for that from org.bucket and the copy partial matches on that. Then we pass args0 here. We pass the arguments.keys for all the valid arguments and our valid arguments array where the valid arguments should be copied to. Again, if you want to learn more about this, watch episode number 7. And this is how it looks in game now. As you can see, we now have our arguments and they are auto-completed as well if you press tab. And now we can continue with the logic of our create game argument. So inside here, we first need access to our messages object and the game manager. So create references here, messages, and private final game manager, and then create the constructor for that. The full command that we want to allow here is /SkyWars create and then a name for the game. So we first need to check if a name is provided. We do that with if args.length is less than 2. Then we want to send the player a message that this command is not correct. And again, those kind of messages I don't like to put in the messages.yml. So they are hard-coded here. And I do that with component.text. And then I pass the correct usage here. SkyWars create name in named text color.red. And if you want to have the prefix in front of that, you need to go back to the messages and create a get prefix method. And you can then just prepend it here with messages, this dot messages dot get prefix dot append, and then put this here and return. And now there won't be a space between the prefix and the message. So let's go back to the messages. And here where we assign the prefix, we can just append a space. and then we can remove the append space from here as well. And now the spacing should be automatically correct if you call the getMessages, the getMessage method, or the getPrefix method. Then here we're just going to call the manager and create the game, just like before. And then we're going to send the player a message that the game has been successfully created. But before that we need to extract the name from the command. So final string name, and this is args01. And then we need to update our create new games methods to accept a name attribute. So for now we can just paste it here, and then we can update our two methods here. So string name and string name. And by the way, I believe you can simplify this a bit and make this method use this one. So here type return, create new game, pass the name, and for the settings we will just use the default settings. And then here we need to do something with the name, so we can pass it in the game object, and now we need to update that as well. String name, then create a global variable, private final string name, and assign it. And we can also create a getter for that. If you know what Lombok is, you can use this library of course to get rid of all the boilerplate code. And now as you can see we need to update our deserialize, and because of that our serialize methods as well to use the new name attribute. So the constructor now expects, besides the game settings, a name, and we can just get it from the data map. So data.get, and then type name here and cast that to a string. And inside the serialize method we now need to specify that the name should be saved to the config as well. So name, and this will be getName. And if we are here we can create a custom ID attribute as well. So here create a new global attribute, private final UUID ID, then assign it here. This dot ID is UUID.random UUID, create getters for it and a setter as well, which you can only do if you make this unprivate. So set ID, and then here save the ID under the name ID, then get ID, and in the deserialize method you need to use game set ID and then get the ID from the data map. And this actually needs to be getID.toString because we can only save strings to the config. And inside here we now need to use UUID.fromString and then get the UUID from the data map. So get, then ID, and cast that to a string. And now if you remember, in the game manager we used UUID.random UUID to generate the UUID, but now the game handles that and we can just replace this with game.getID. Okay, now back to the create game argument. We now have adjusted the create new game method to accept a name parameter, and now we can send the player a message that the game has been created. So player.sendMessage, messages.getMessage, and now we need to create a new message type. For example, I want to make this as general as possible, so I'm not going to create a game created message, but an entity created message, entity created, and then we can just use placeholders in this method to say, for example, that a game has been created or that a new spawn for a team has been created and so on. So copy the path and paste it here, and the entity created message will be in green, and we use a placeholder, and I call that entity for now, has been created, or let's say has been updated. And then in the create game argument we can use this new message type, so entity created, and then we can use placeholder.unpassed, and we use unpassed and not passed to escape any user input. This makes it a bit more secure. And we just replace entity with game. And then in the end the message says in green color, game, because we replaced this placeholder, has been updated. Or let's do created. And this is already it with the create game argument, so close the file. And now in the SkyWars command you need to pass the messages to the create game argument, so type messages and the game manager. If you get an error when you try to start the server that is caused by the serialization, then this is because we just changed the serialize and deserialize methods, but in our config we still have old data that doesn't use the new fields that we have created. So to fix this, just delete the config and restart the server. And now if you try to create a new game, SkyWars create test game. Okay, now we get our not found message because we still have the old messages.yml where the new messages that we created are not inside yet. So to fix that, delete the messages and restart the server again. And now let's create a new game, create test game. You can see the message works now. We look at this in a moment. And in the config, you can see now that the game has been created. And to fix that, you need to go to the messages class, and we forgot to use the placeholders. You can see they are gray. This means the variable has not been used. So do check resolver.resolver and pass the placeholder. Now create a second game, and you can see that the replacement works. Now we're going to handle the locations of a game, so the lobby location and the team locations. And for that, create a new class in the game package and call it game locations. And inside here, we're going to define a location, which is the lobby location, and a map to hold all the team locations. So map, we're going to use a game team object for that, which we haven't created yet, and then a location as the value. Spawns, and this is a new hash map. Then in the same package, create the game team enum, and here we just define the available teams. So in my game, I want a blue team, a red team, yellow team, and green team. And then let's create a set lobby method, get lobby method, and a method to get the spawns. And now we do the same as with the game and game settings objects. Since we want to save the game locations in a configuration file, we need to implement configuration serializable, then implement the serialize method, and then return everything that we want to save in the config. For this object, we want to save the lobby. The value will be get lobby. And the spawns we have to treat a bit differently because we cannot save an enum to the config. We first need to convert the enum to a string. So in here, create a map that holds a string instead of a game team, but still location objects. I will call this temp spawns, and this will be a new hash map. Then we loop through every available team for game team of get spawns dot keyset, and in here we're going to populate the temp spawns map with temp spawns dot put. The key will be the team dot name to convert it to a string, and the value will be get spawns dot get team. Because the type of the location didn't change, we can just copy it over. And now we can serialize the spawns with spawns and temp spawns. And now let's create the deserialize method to read from the config. Public static game locations deserialize map string object data. And let's create a game locations object first. And locations.setLobby will be data.get and then lobby, because this is the name where we saved the lobby under, and cast that to a location. And now to save the team spawns, we need to make the opposite of this. So first get the map from the data map, final map string location spawns, temp spawns, and this is data, get and spawns. Then cast this to a map and create a for loop. For every string, call it team string of the temp spawns.keyset. We're going to convert that to the game team enum, final game team, and call it team. This is game team dot value of temp team string. I see I made a typo there. Team string, and then we need to access the locations object and set the spawn for the team, and the location will be temp spawns get team string. Let's create that method, and inside here we just do this dot spawns dot put team location. Let's move the method up a bit. And now we just need to return the locations object, this one. And then the next thing we need to do is to register this configuration serializable, just as with game and game settings. So go to the main class and register it like this. And now we need to go to the game class and define that every game should have a reference to a game locations object, the same as we did with the game settings. So create a new field, private final game locations, and this can just be equal to this locations new game locations, and in the game manager we say we now want to expect a location for the lobby as well here, and in the other create game method as well, and don't forget to pass it here. Inside here we need to access the locations object of the game, so create a new get locations method and call it here game.getLocations set lobby. And then in the create game argument, since we use the create new game method here, we need to update the parameters as well, because now we want a lobby location, and we just say the lobby is by default the location of the player where the command has been executed. So player get location. And then inside the game we need to adjust the serialized and deserialized methods as well to now include the location. So first the serialized method, locations, get locations, and now the deserialized method. And for that we need to create a location setter, and this means it cannot be final. So set locations. And then inside the deserialized method we just call game set locations and data get locations and cast that to game location. And now if we create a new game, you can see now it contains a locations object, and by default the lobby spawn is already filled out with the location that the player is currently at. And now the next and last thing for this part will be a subcommand to create spawns for each team. So create a new argument in the arguments package, set team location argument, and this implements argument executor. The usage will be spawn and then a team, and the description will be set spawn location for a team. And the final command will look like this, /skywars spawn team. It has 2 arguments, so if args.length is less than 2, then we're going to send the player a message, and for that we need the messages reference and create a constructor. And then in red color we first send the correct usage, SkyWars spawn team return, and we actually need a reference to the game as well, so like this, and then add one here. And now we need to check if the game that the user specified here actually exists, and for that we're going to create a new method in the game manager. It will be a public optional game get game, and the parameter will be the game name. And optional is just something that can hold a value or not. So in this case the optional can be empty or hold a game. And here we just need to return games, so this set of games here at the top, then stream and filter to check if there is any game with the name that we entered here. So game get name dot equals name and find first. And we need to make sure that inside the create new game method we add the newly created game to the games set. So this dot games dot add game. Then back to the set team location argument. We now need a reference of the game manager as well. Private final game manager and adjust the constructor. And then inside here we call the get game method. So final optional game is equal to manager.getGame with the name which is saved in this argument, which is 0, 1, 2, so args2. And then if the game is not found, so if optional game.isEmpty, we send the player a message about this. Send message, messages.getMessage, create a new message type. And for the same reasons I explained earlier, I will call this new message type entity not found. The path will be entity not found. Let's copy the path and create it. And here we say in red color entity, then yellow color name not found. And inside the set team location argument we now can use this message type entity not found, and we need to replace the placeholders. We have 2 placeholders. The first one is the entity, so placeholder unpassed entity, and in this case it's a game that could not be found. And the second placeholder is the name, and the name is whatever the player entered in here, so args2, and then return. Now we can get the game from the optional with final game is equal to optional game.get. Then we also get the team that the player entered here. Final string team argument is equal to args.1. And now we need to check if the team that the player entered here is a valid enum entry from the game teams. So either blue, red, yellow or green. And you can see those are all uppercase. So let's transform that to uppercase as well. And now we need to try catch block. Final game team. Team is equal to game team dot value of team argument. And this just converts this team argument string to a game team. And if this is an invalid enum entry, it will throw an illegal argument exception. So we need to catch it here. And we send the entity not found message as well. So we can copy it from here. This time the entity is not a game, but a team. And the name is team argument. So this is it for the catch block. And now inside the try block, we want to get the game, get the location object, and on here set the spawn for this team. So now open the locations, the game locations class, and you need to make this set spawn method public if you didn't already had it public. And then here call set spawn, pass the team, and player.location as .getLocation as the location. And then we can use the entity created message to inform the player of this with player send message, messages.get, message type, entity created, and the placeholder will be entity and it will be replaced with team spawn. Now the last thing we need to do is to set the argument to the SkyWars root command, same as here. So arguments.put spawn, and the value will be a new set team location argument. And at here we need to pass the messages and the game manager. And now let's see what it looks like in game. Okay, now let's execute the command again. You can see the spawn subcommand has automatically been added. The usage works. And now let's try with an invalid team and game. At the moment we only have a test game. So let's do test2, then game test2 not found. Now let's use an invalid team only, team test not found. And now let's enter a valid team. Team spawn has been created. And now the location object has been updated in memory. The only thing left is we need to write it to the config file as well. And we can do that when the server shuts down, just to improve performance a little bit. So inside the game manager, create a public method, public void save games. And here we're going to loop through every game and call save game to config on that game. And then we just need to call this save games method in the main class, specifically in the onDisable method. So manager, to make this globally available, private game manager, and this.manager. Then inside here, call manager.saveGames. And now if we execute the same command again and then shut down, you can see that the location has been added to the config file.